In the previous video, we talked about first order linear equations, and we said they're always written this way. They might not completely directly be written this way, but you could actually rewrite them or rearrange the equation into this form. Now, if you are given an equation of this form and required to find out what is the solutions to it, you would need to create an integrating factor, which is represented by rho, and rho is equal to exponential p dx. Now in this case, p is a function in terms of x, and q is also a function in terms of x. And from there, you need to make y the subject, and that will be equal to integral rho q dx plus c, and multiply by rho to the negative 1. And we said this is basically going to be the solution to a first order linear equation. Now the problem is you might not always be given of linear equations. Now if an equation is not exactly linear, you could actually change it into linear form. Now one of such equations is actually the Bernoulli's equation. A Bernoulli's equation is written this way. That is y to the negative n dy dx multiplied by p. Well, that is added rather by p multiplied by y to the negative n plus 1. And this is equal to q. This is how a Bernoulli's equation looks. And you could actually be given a question or an equation that looks like this and asked to find out what is going to be the solution to it. So this video breaks that down. Now, in order to find out what will be the solution to a Bernoulli's equation, you need to make this value, or this variable rather, to be a new stuff or a new variable. So we're going to say let v be equal to y to the negative n plus 1. Very important. Now we need to differentiate both sides implicitly. That is going to be with respect to x. So that will be dv dx. And of course that is an implicit differentiation because obviously we do not really have x variables within this equation. So we're going to have an implicit differentiation, obviously. Now, to work this, we need to use the power rule. So that is going to be a negative n plus 1. That is taking the power to the front. And you need to work this. That is the derivative of this. So that is going to be y to the negative n plus 1. And you need to subtract 1 from there. We know that dy dx, that is the power rule. That should be equal to x multiplied by n. Well, I think I mistook this. There should be n multiplied by x raised to the power of n minus 1. So if you had y and that were equal to x to the n, you could well find out what is going to be of the derivative of it. So you need to take n to the front, which is what we did here. We know the power of y in this case is negative n plus 1, and that is the reason we took it to the front. And you need to subtract 1 from the power. We know the power is a negative n plus 1, so we need to take 1 away from it. And that is going to cause up the 1 to get eliminated. So you're going to have something like this. That will be dv dx. And that is going to be equal to, I'm going to rearrange this. So we would have 1 minus n. And this is going to be y to the negative n. Now, this is what you're going to have. Now, I could well take this away from here and divide through by it. So dividing through, that will give us 1. Or I'm just going to take it more gradually. So what I'm going to do, I will take the reciprocal of this and multiply through this whole equation. So that is going to be 1 divided by 1 minus n. And that will be multiplied by dv dx. And that is equal to 1 minus n. And you're going to have a y to the negative n. So this is what you have. Now, if I multiply this by this, okay, so that will give us a 1 divided by 1 minus n dv dx. And on this side, if I took this and multiplied it with this, that is going to cancel these out. So we would just have a y to the negative n. So that is what you're going to have. Now, the next thing we need to do, so I need to take this out. The next thing we need to do is We know that there is a y to the negative n and a dy dx over here. So what we're going to do is we would make up y to the negative n dy dx. So this is dy dx. We're going to make it to be equal to 1 divided by 1 minus n dv dx. That is what we're going to have. So I'm going to wipe this out. Now we already know that we have this from the initial Bernoulli's equation, so I'm going to replace that. Now this stuff we said that should be a v, right? We said v, let it be equal to y to the negative n plus 1, right? So we're going to have this as 1 divided by 1 minus n, and this is multiplied by dv dx plus p multiplied by v in this case, and that will be equal to q. So that is what you have. Now we need to force this equation and take it back to a first order linear equation. That is making the first function to be a differential function. So we need to take this away, and that will be basically by multiplying through by 1 minus x. So let us multiply through by 1 minus x. So that will be 1 divided by 1 minus n. Well, that should be 1 minus n. Plus pv, and that is equal to q on the other side. So I'm going to take this out now. Now this is going to cancel this for this part. So this gets cancelled, and we would have a dv dx, and on this other side we're going to have a 1 minus n multiplied by pv. So that will give us a 1 minus n. So I need to rewrite that. 1 minus n multiplied by pv. This will be equal to q, or 1 minus n multiplied by q. That is what we're going to have. Now this expression is a new form of a linear expression. And from here we can find out what is the integrating factor. So the integrating factor rho is going to be e raised to the power of this. Now in this case we have a v for the measure integral. So, well, not an integral, that is a differential. So we're going to have 1 minus n multiplied by p to be the stuff which is actually the coefficient of v. So in this case we should have the integrating factor to be 1 minus n and multiplied by p d. In this case we're going to have it as dx because obviously there must be a dx somewhere around there. Remember we differentiated it with respect to x here, so that should come off easy. So that is a way to do it. And then next up you're going to use the other formula which we talked about to find the value of y, right? So we're going to do that in a little while, so we're just going to go through some questions and find out how that really works. So here is the first question for us. We have dy dx minus y is equal to x y to the fifth. Now we know that the Bernoulli's equation is written as y to the negative n. dy dx, that is plus p multiplied by y to the negative n. So I need to rewrite that, n plus 1, and that is equal to q. And p and q, they are functions in terms of x. Now, in this case, we do not really have y to the negative n for the initial equation, so we need to make that work. That is basically by dividing through by y to the fifth. So that is going to be 1 over y to the fifth on this part, dy dx, and this is going to be minus y divided by y to the fifth, and this is going to be x y to the fifth divided by y to the fifth. So here we can have these cancel out, and we're going to have y cancel one of the y's away, and that will leave us with the y to the fourth. Now this is basically going to change to y to the negative 5. So this is what we got here. This is dy dx minus 1 divided by y to the fourth. That is equal to x. So we know we could rewrite this stuff. and that will be written like this. That will be y to the negative 5 dy dx minus y to the negative 4. So I'm just having some problems writing that out. Okay, so that is what you have. So this is the real Bernoulli's equation from this place. Now next up, we need to analyze it and bring out the stuff which we need to bring out to solve the equation. Now we know that this is the same thing as this, right? Now from the first part of this video, we said that y to the negative n dy dx is the same thing as 1 divided by 1 minus n dv dx. That was actually derived. So we know in this case that n is equal to 5 for this. That is what we have. So we're going to have a y to the negative 5 dy dx. That will be equal to 1 divided by 1 minus 5 dv dx. So this is equal to negative 1 over 4 dv dx. Right? So we have that worked out. Well, need to write it. Y to the negative 5 dy dx, that is equal to negative 1 over 4 dv dx. Need to rewrite this again. So that is what we have for the first part. Next up, we need to work what is going to be this part. So we know n is equal to 5. And we said that v must be equal to y to the negative n plus 1, right? So what is n? N is 5, so that is y to the negative 5 plus 1, and that is going to be equal to y to the negative 4. That means v is equal to y to the negative 4. And so this stuff is going to be a v. So we need to plug all these back into perspective. The first one, which is this, that is y to the negative 5 dy dx. And in this case, we have it to be negative 1 over 4 dv dx. And then we have minus y to the negative 4. Y to the negative 4, that is the same thing as v. So that is a v, and this is equal to x. Now, this is the new form of the Bernoulli's equation. We need to change it into a linear equation, a first order linear equation. Now, in order to do that, we need to multiply through with the negative 4. So this is going to be minus 4, and that will be multiplied by minus a fourth dv dx minus v equal to x. That is what we got. I'm multiplying this with this. That is going to give us a positive 1 because 4 is going to cancel 4. And a negative will multiply with this to give us a positive. So we're just going to have a dv dx. Now here we have a negative 4 multiplied by a negative v. That will give us a plus 4v. On this side we have a negative 4 multiplied by x, and that will give us a minus 4x. So that is the new stuff that we got. So this now is going to be the real linear equation. We have a dv dx plus 4v, and that is equal to minus 4x. So we need to work this. Now in order to work it, we need to find the integrating factor, which is going to be e to the integral of p dx. So what is p from this equation? So we know that p, that must be equal to 4, and q, that is negative 4x. So rho is going to be e raised to the power of integral 4 dx. So the derivative, well, the integral rather, of 4 dx, that is going to be e to the 4x. So we have rho. Rho is equal to e to the 4x. Next up, we need to find what y is going to be. Now, in this case, should we call it as y? Because initially we had dy dx, that is for linear equations, and so y will be equal to whatever. In this case, it's a v that we have. So it is the v that we need to find. So v is going to be equal to integral rho q dx multiplied by rho to the negative 1. So what is rho? Rho is e to the 4x, right? And we have q. Q is minus 4x. And we have dx. This should be multiplied by rho to the negative 1, right? So I'm going to take these ones out. Okay, so bringing this 4 out, we're going to have that v must be equal to a negative 4. So I should write this. Integral x e to the 4x dx and rho raised to the power of negative 1. So we need to work this integral. Now working that, we need parts. So let us try to work it. So this is x e to the 4x dx. Now in this case, we're going to make x to be as u. So u is equal to x. And therefore, du will be equal to 1 dx. Next up, we need to make this to be dv. So dv is equal to e to the 4x dx. And v, that is by integrating both sides. Integrating dv, that reduces to a v. And integrating e to the 4x, that is going to be e to the 4x multiplied by 4 to the negative 1. Because we have this to be dividing into this. So that is what we're going to have there. Now we need to take it back into the original stuff. So I need to, well, I'm going to wipe this one out. And this one, yeah. And this one also. I'm going to place this rho on this side. So this e to the 4x. So that I can have more space here. So we know that integral u dv, that is the integration by parts, that is uv minus integral v du, right? So u in this case is x, and v is e to the 4x multiplied by 4 to the negative 1 or divided by 4. So this is the same thing, and we have integral v, which is the same thing, that is 1 over 4 multiplied by e to the 4x. Du in this case is 1 dx, so I just need to write that there. So this stuff is going to come out. So this is going to be 1. Well, this is x e to the 4x all divided by 4. And this is minus 1 over 4. Now integral e to the 4x is what we have. Now what is going to be the integral of e to the 4x? What is that going to give? So basically that should give us e to the 4x divided by 4. I think I could wipe these out for now. So we're going to have x e to the 4x divided by 4 minus 1 over 4 multiplied by e to the 4x divided by 4. Okay, now since we have this as the only integral, we should have a c right now. So this is going to be x e to the 4x divided by 4. And this is going to be 1 over 4 multiplied by another 1 over 4. So that would give us 1 over 16 multiplied by e to the 4x plus c. That will be the integral of this stuff. So let us keep that in perspective. Well, I'm going to take these out now. So we have v. V is equal to negative 4 multiplied by x e to the 4x divided by 4. That is minus e to the 4x divided by 16. And this is plus c. and then we need to have rho to the negative 1. Now rho to the negative 1, that will be e to the negative 4x, because we have a rho to be e to the 4x, so that should be e to the negative 4x, right? So finally, v will be equal to negative 4 multiplied by this stuff. That is going to cancel these out. So we would actually have these cancelled, and we would have a negative. So that is a minus x e to the 4x. And here we have a negative 4 multiplied by negative this. So that is going to cancel this and create a 4 there. So we should have a e to the 4x divided by 4. And this is plus this c. And here now we should have e to the negative 4x. So this will be the answer to the question. That is the value of v. So pretty much it in it. Now what if you were required to find out what will be the value of y? Because from the original equation we do not have a v. But we know what v was. What did we say v was? V, that was equal to y to the negative n plus 1, right? This is v, so I'm going to take this out. Now, v is equal to y to the negative 5 plus 1, so that was y to the negative 4, right? So if we have v to be equal to y to the negative 4, how then can you find y? So we would need to take the power of a negative 1 over 4 to both sides. So that is to the power of negative 1 over 4. This will be y to the negative 4 multiplied by negative 1 over 4. So this is going to cancel this, and we would have a negative 1 multiplied by negative 1. That will give us a y to the power of 1. So v should be equal to the negative 1 over 4. So that will be the value of y. So let us just plug that in and see what it's going to give us. So y, that will be equal to this stuff. So that is to rewrite it. So this is minus e to the 4x divided by 4 plus c multiplied by e to the negative 4x, and this should be raised to the power of a negative 1 over 4. That is what is going to be the value or the answer for y. So if you want to find y, this is actually the answer to it. Now here is this is actually going to be the last question for this video. So you could well try solving other questions under the Bernoulli's equation from the extrapolations which you would of course make from this video. So how can we solve this question? Now we need to find out what is the Bernoulli's equation. We need to have y to the negative n dy dx plus p y to the negative n plus 1, that equal to q. So of course you need to take out all the y variables from the other side of the equality sign. So we need to take y squared away from here. Now that will be by dividing through by y squared. So that will be 1 divided by y squared dy dx, and here we're going to have a y divided by y squared, and on this side we have y squared divided by y squared, and you're going to have a cosine x minus sine x. So here you should have this cancel one of it, and here is going to cancel everything. So you would have y to the negative 2 dy dx, and here we basically have a 1. Whoa, that is 1 divided by y. I'm just going to make this to be y to the negative 1 at once. And so this is equal to cos x minus sine x. So that is the new equation we have. This is the proper Bernoulli's equation. Now we know that the Bernoulli's equation y to the negative n dy dx, that must be equal to 1 divided by 1 minus n dv dx, remember? So here we have y to the negative 2 dy dx. And you can well see that n therefore is equal to 2. And so we should have 1 divided by 1 minus 2 dv dx. Now 1 minus 2, that is going to give us a negative 1. So we should have a negative 1 multiplied by dv dx, right? So this is basically a negative dv dx sticking out there, okay? So that is what we have. I'm going to write it here. Y to the negative 2 dy dx, that is equal to negative dv dx, okay? First extrapolation. And the next off is what y to the negative 1 is. Now remember we said v is always y to the negative n plus 1. Of course here we have n to be 2. So v is equal to y to the negative 2 plus 1. This should be y to the negative 1. So this stuff is actually v. Now v is equal to y to the negative 1. Now having got all this, we're going to change this into a linear equation, a first order linear equation. So this stuff we said that should become something like this. And in this case, we have already said that we're in over this part. So that is negative dv dx. And then we have plus v, and that is equal to cos x minus sin x. Oh, I need to rewrite this. So this is what you have. I'm gonna wipe this out. Now we need to take this negative away. I would basically multiply through by negative 1 to take this away. So multiplying through, that should give us a dv dx. You're gonna have a negative v here now. And so here you're gonna have a negative cos x minus sin x. Now this is gonna change in it. So we should have a dv dx minus v, and here you're gonna have a positive because multiplying this with this, that is a negative 1 multiplied by cos x, that gives us a negative, and this is gonna give us a positive. So I will write it in front of the other one this way. Exactly. So that is what you're gonna have. So in this case, I believe I can wipe these out. So the next thing you need to do, we need to find out what is the integrating factor. Before then, we should find out what is p. So p in this case is a negative 1 because that is what is multiplied to pv. Remember, we must have something like this, dv dx plus 1 minus n multiplied by p multiplied by v, and that is equal to q multiplied by 1 minus n, right? Now in this case we have a v and we have a minus 1. So this is obviously going to be the whole of this stuff, right? So that is what we have. We're going to use it. And q is equal to this whole stuff. That is sin x minus cos x. So we can now go on. We need to find the integrating factor. So that is exponential integral, that is p dx, right? So what is p? That is a negative 1 dx. So this should be e to the negative x, right? So that is what we got. So we have rho. Rho is equal to e. That is equal to e to the negative x, right? So let's look at that once more. Yeah, that is correct. So I'm going to take these out again. So the next step, we need to find v. So v should be equal to integral rho dx, rho, that is rho q dx. and we would have a rho to the negative 1, right? Well, that is what we should have, basically, right? Okay, so first off, we're gonna work. Well, let's just take it gradually. We know this is a rho, so rho is e to the x, or e to the negative x. And q in this case is sine x, and then we have minus cos x dx, and this is multiplied by e to the negative x to the negative 1, because rho is e to the negative x. So well, let's just make it gradual. Okay, so we need to work this. How can we actually work this stuff? How can we solve it? So v is equal to integral e to the negative x multiplied by sine x minus, okay, I'm gonna make it dx, minus integral e to the negative x multiplied by cos x, and you would have dx. And then this must be multiplied by rho to the negative 1. Bear in mind, rho itself is actually e to the negative x, so we need to find out what that is and multiply the answer to the negative 1. So this should actually be an e to the positive x. So we need to work this. We need to find out what is going to be the answer to this. Okay, so let us work this. I'm going to take this part out. We really need some space here, so I need to wipe this stuff out. So we need to wipe these also. Now here we just need to remember that rho, that is the integrating factor, that is e raised to the power of a negative x. Later on we're going to add that back into perspective. So we're going to take these out. We need to take these out also. So what we got here now is v, and basically we need to work the integral, that is integral of e. Well, I need to read this. So that is integral e raised to the power of a negative x sine x dx minus integral e raised to the negative x cos x dx. Right. So this is what we need to work, and later on we need to multiply this with a rho raised to the power of a negative 1. So we're going to do that later on, but for now, let us work this stuff. Now the first thing I'm going to do is let a be equal to integral e to the negative x multiplied by sine x dx. Okay, so let us work this. Now b, before we work it, let us just find out b. Let it be equal to the integral of e to the negative x cos x dx. Therefore, to find the integral of this stuff, I, that will be equal to a minus b, right? So you just need to bear this at the back, very important. So I'm just gonna take it out for now. Okay, so we're just gonna work with a for now. I'm gonna take these out. Okay, so for the a, we have this, and so we need to find what the value is gonna be. Now in this case, I'm gonna take up u to be equal to e to the negative x. So we need to find du, that will be minus e to the negative x, basically, and that will be multiplied by dx. This is going to be the derivative of this stuff. Now next up we have dv, that is equal to sine x dx. So basically I am working this integration by the method of parts. So we need to integrate dv, that is going to give us a v, and the integral of this is basically going to give us a negative cos cos x dx. Now you know that integral u dv, that will be equal to uv minus integral v du, right? So integral e to the negative x sine x of dx, that is equal to u. Now u in this case is equal to e to the negative x, and v is negative cos x dx. Well, I need to take this out. So we shouldn't have written out a dx there, because we already had a dx there, so stuff is already worked. Now this is minus integral v du, right? So we know v is minus cos x, and du in this case is this stuff. So that will be minus e to the minus x dx, right? So I'm gonna take this out and rewrite it up here. Now on this part, you can see that we have a negative here and another one there. So they would actually get multiplied and ring out, so that would make it positive. Now here we're gonna have so this is what we should have. This is a minus e to the minus x multiplied by cos x. And here we're gonna have plus integral e to the negative x multiplied by cos x, and you have dx. Okay, so we should have a negative here, so that is actually supposed to be there. Okay, yep, so we are actually correct. There is no error here, right? Now we know that a is equal to this stuff, right? We said a is equal to this, and then we said b is equal to this, right? So in this case, what we're going to say is that the integral of a, right? That is trying to find this, the integral of a, or the value of the integral, that is equal to negative e to the negative x multiplied by cos x minus this stuff, and we already said this should be a b, right? So this is going to be a b, and I'm going to write it that way. So we just need to hold this one at the back. So I need to place it somewhere very important. I think I'm gonna write it up here. So let us place it up here. A is equal to negative e to the negative x cos x minus b. Yep. So basically that is what we got. Now next up, we need to pick out b. So we said b is equal to integral e to the negative x, and that is multiplied by cos x dx, right? Right, so we need to work this again using parts. So u is going to be equal to e to the negative x, so du obviously is a minus e to the x. So minus e to the minus x, and then we need to bring out what dv is. dv in this case, that is going to be cos x of dx. So integrating it, that changes dv to a v, and on this side we're going to have a sine x commonly. So as you well know, that should be integral u dv. This is equal to uv minus integral v du, right? So the integral of u dv, that is this stuff, and we called it a b, right? So I could well just write that as a b there. And here we're going to have u, which is equal to e to the negative x multiplied by v. V in this case is sine x. So this is minus integral v. So that is sine x multiplied by du. Du is the stuff. Well, I needed to place a dx on it because that is the derivative of u, and that must be with respect to x. So multiplying it to this other side, that is going to create that there. So we'll have a minus e to the minus x dx, right? So I'm going to wipe these out. So from here, you're going to find that b is equal to e to the negative x sine x. And this will be minus integral. Well, in this case, you can find that we have a negative here. So that would actually go out and multiply with this. So that would create a positive there. And so here we're going to have an e to the negative x multiplied by sine x dx. So this is what we got. Now, like we said initially, we said that e to the negative x multiplied by sine x dx, we call that an a. That is the derivative of it. This stuff here, we called it an a. So b now is equal to e to the negative x multiplied by sine x plus an a. So that is what you got. Just need to write this out. So this is what you got. Now, the next thing that I will do in this case actually is I could well take this stuff that is a b and plug it as a b within the first equation. I can do that, right? So let us try to do it. So that is going to give us a, and this is equal to negative e to the negative x multiplied by cos x minus b. Now b is equal to e to the negative x sine x plus a. And so a is going to be equal to negative e to the negative x cos x minus e to the negative x sine x minus a. So I could take negative a to the other side, and so that would give me 2a, because this is going to be a positive a plus this. So that gives us 2a. And here now we're going to have a minus negative e to the negative x. Well, that is minus e to the negative x typically. Here is also something we have. So that is what we're going to have. This is minus e to the minus x. So that is what we have there. And we have minus e to the minus x sine x. So here now we find out this stuff could well be factored out. So let us try to do that. I'm factoring that out. That is going to be minus e to the negative x into cos x plus sine x. Okay, so a now, we could well tell what a is from this place. So a from here is actually going to be negative 1 over 2 e to the negative x. That is dividing through by 2, right? So this is going to be cos x plus sine x. That is what you're going to have there. So this should be the new form of a, right? So I'm going to highlight that in blue. Now next up, what we're going to do, we're going to take this a and substitute it for a in b here. So b is going to be equal to e to the negative x multiplied by sine x plus this stuff. That is a negative 1 over 2 e to the negative x. And you have a cos x plus sine x. Okay, so this is what you got. Now b will be equal to e to the negative x sine x, and here we're going to have a negative e to the negative x. So we got this multiplied by this. That would give us a cos x there. And so using a positive 1 to multiply with that, that is going to give us this. Now using positive 1 multiplied by this, that is going to give us a negative half of e to the negative x. Now we need to use this and multiply with this, right? So that is going to give us a negative 1 over 2 e to the minus x sine x, right? So what next are we going to have? In this case, we find out there is an e to the negative x sine x, and there is another one here. So they're basically going to come together. So I think I'm going to take these out now. So b is equal to e to the negative x sine x minus a half of it, and we're going to have a negative 1 over 2 e to the negative x cos x. Now we have one of this here and then minus a half of it. So that will leave us with a half. So this is 1 over 2 e to the negative x sine x, and this will be minus 1 over 2 e to the negative x cos x. Now here we know we could well factor out a half e to the negative x, or at least, yeah, basically, that is what we're going to have. So that is just what I'm going to do there. B in this case is equal to 1 over 2 e to the negative x, and here you have a sine x minus cos x. So that is what you got. This is B. Now remember, we wanted to find I, and I was equal to A minus B. Remember that? So we're going to bring that in now. And so I is equal to A minus B. So we need to work that. So this is going to be 1 over 2 e to the negative x, and we have a sine x minus cos x. That is, well, this is B. I'm actually writing B before an A. That shouldn't be. So this is a negative 1 over 2 e to the negative x. And here we have a cos x plus a sine x. That is minus B. So that is 1 over 2 e to the negative x sine x minus cos x. So that is what you have. Now, in this case, we have a negative half e to the negative x and this. They're actually the same, so we could well factor them out. So I need to write this out better. So this is going to be negative 1 over 2 e to the minus x. And so we would have a new stuff here. So this should be a cos x plus a sine x. And here now we're going to have a plus sine x minus cos x. Now from here you can see that cos is going to cancel out. So we would have these two stuff create a 2 sine x. So we have I is equal to minus 1 over 2 e to the minus x, and then you have a 2 sine x. Now obviously this should be a plus c. So we're going to have I to be equal to, now 2 can cancel these out, so we should have a minus e to the minus x sine x plus a c. Now remember, originally we had v was equal to integral e to the negative x sine x dx minus integral e to the negative x cos x dx multiplied by rho, right? And initially we said, as usual, rho is equal to e to the negative x, right? So we're just going to take all these and plug them back and find what that is going to give. This should be a rho to the negative 1. So v, that is equal to, this whole stuff is equal to this. So that is negative e to the negative x sine x plus c. That is equal to, well, that is multiplied rather by e to the negative x all raised to the power of a negative 1, right? So the final answer, or v rather, that is equal to minus e to the minus x sine x plus c. And that is multiplied by e to the x, since we have negative x multiplied by negative 1. So what is then going to be y? How can we find y? Now remember, we said that v was equal to y to the negative 1, right? So y will be equal to v to the negative 1, basically. So we're going to have y. That will be equal to negative e to the negative x sine x plus c multiplied by e to the x. And this will be raised to the power of a negative 1. So that will be the answer to the question. Pretty long stuff in it.